All right, let's get started. So you guys have now seen all the lectures that you're going to need for Tuesday's exam. Okay? So we'll start today with questions that you guys might have, and then with whatever time we have left over, one second, we're going to start talking about the next phase of the course, which is where we have to worry about both heat effects and chemical reactions at the same time. Up until now, we've always operated under the assumption that all of our reactors were isothermal. And like I said, we're going to lose that assumption soon. Thursday, if we have class, because of this Hurricane Matthew thing, will be all review. Essentially, I'm going to bring in some problems from old exams, and I'll just kind of do them on the board with you guys helping out. Okay? All right, questions?
Yeah, are you going to put up some practice exams on how you word your questions?
I've never worded a question before, so I have no practice exams. You guys forget, this is my first class. So I don't have any practice exams to give. Like I said, Thursday we're going to go over an old exam I have from an old teacher. But I can't promise that the wording and stuff is going to be consistent because I'm going to write our exam from scratch. I will put up, though, Thursday, right after you guys turn in your homeworks, and we'll worry about the hurricane when it happens, I'll post the solutions to the last homework problem. So you guys will have all the homework solutions on there. And if you guys want, I can post class notes, but I don't promise that they're readable because when my TA tried to scan these, a lot of them didn't scan very readably. Yes?
I guess I'm trying to answer it, but the exam encompasses all four homeworks?
Yeah, the exam is everything that you've learned thus far. Except, like I said, if we start talking about heat effects today, that's not going to be on there. Yeah.
Well, two questions. The first one is, you said we'd be allowed to bring some kind of notes with us to the exam?
Yeah, one sheet of paper, front and back. I don't care what you put on it as long as it fits on, in like a normal sheet of paper, right? Not like,
Parchment paper?
yeah, not a newspaper or anything, yeah.
The second question is, what do you suggest is the best way to prepare for the exam? Just review the homeworks?
I think so. I think, like I said, the homeworks should be more difficult than the exams. So if you feel like you know the homeworks, I mean, the thing with chemical engineering that hopefully you guys know by now, there's always a little bit of a twist to every problem. So just because you know the twist to a homework, now that problem looks really, really easy, right? So I think in that sense, if you just look at the homeworks, you might be misled because it's probably not going to be the exact same twists in the exam, right? There's other problems in the back of the book. The homework solutions, at least for the fourth edition, I know they're floating out there. So you guys have, and a lot of those problems are also in the 5th edition. In fact, pretty much everything that I've pulled from has been in both editions. So you have other examples of homework problems you can try. Okay, any questions about content?
So today's lecture is not going to be on this?
No. No, we're going to start talking about heat transfer. I thought I had one more pack of notes that were about multiple reactions, but I didn't. So we're a little bit off. We probably should have had the test Thursday, but you know, then we definitely would have had classes canceled if I would have had the test scheduled for Thursday.
Can we review today just in case of Thursday?
I don't have the review materials. I'm sorry. If I knew that there was a threat of this, I'd have brought the review materials. But yeah.
If class is canceled on Thursday, is the homework that due on Tuesday?
Yeah, I don't care. We'll say Friday, whenever, let's say just whenever campus, yeah. Friday, Monday, whatever. I mean, do it so that you can start studying for the exams. But I'm not that obsessed about the due date for the homework. Yeah.
How many questions will be on the exam, and how long do we expect it to take?
So I'm not saying expect it to take 2 hours, but you're going to be allowed the entire 1 hour, 55 minutes that this class is scheduled for. Probably 3 healthy problems and maybe 1 small one. So somewhere between 3 and 4 problems.
Is there going to be any unhealthy problems?
One small one, that's not healthy. Like something more conceptual based that doesn't require a lot of algebraic manipulation, that kind of thing. Now, I mean, for everything, you guys, again, you guys have been through this. If the homework, I mean, if the test average comes back and it's, a 52, there's obviously going to be some adjustments to the grades. So don't be obsessed about, oh, I'm never going to be able to finish 4 problems in 2 hours. If nobody can, then who cares? But you guys are seniors, so I expect that you guys have good test-taking strategies by now. I don't have to explain how to take a test. Well, maybe that's a bad assumption. But you've had practice. Any other questions about the test or any of the material that we've gone over?
That's difficult.
Wait, can I pull up that one specific question?
Yeah, sure.
I wish I had more questions prepared, but I was unprepared considering I thought it was Thursday.
I did too. I looked at my notes this morning. I'm like, I've already given these. Whoops.
Just try it anyway and see if anybody says.
Just do the exact. Yeah. They are slightly different. That's what threw me off. It wasn't the exact same sheets of paper. Oh my God. How do you read that?
That's what I say every time.
This is microfilm. If
Yeah.
anybody's ever seen it before, you put it through a projector and it gets blown up. He just writes in it. No, I'm okay. So you're saying this was an equilibrium problem, right?
Yeah.
And your question was,
How do you deal with equilibrium?
how do you deal with equilibrium? All right. There you go. So the ways in which you can encounter equilibrium. So first you have to have a reversible reaction, right? And so you have little k1 and little k negative 1. And you're going to start, let's just deal with a batch reactor. Things are going to be similar for other types of reactors. So in a batch reactor, the characteristic thing that I'm changing is time, right? With a PFR, it's residence time. With a CSTR, it's simply volume or again, residence time in that case as well. So we just have time, and so up here we have our concentrations of our species. So you start at some concentration of A, and we'll say that you also start at a concentration of B such that the initial concentration of B is 0. Now, if I had this scenario of an irreversible reaction, what's my concentration profile look like with time? If the rate is first order. It goes down. With what shape? Flat line?
1 over x.
It looks like 1 over x, but it's not. So just make sure that you
I know.
don't, yeah. So it's an exponential decay, right? And where does it stop?
Close.
0 if it's an irreversible reaction. Now, in reality, no reactions are irreversible. So you're right in the sense that there's always going to be some equilibrium. But if it's written this way, that just generally means that the equilibrium favors B to a very, very large amount. Over here, yeah, though, instead you're going to stop at some equilibrium value. And so how do we determine what that equilibrium value is if we're given, you could be given these small rate constants, right? Or you could be given the equilibrium constant. So it changes the boundary conditions of your problem once you're doing your integration. In the sense that you're no longer going, the decay will no longer take you all the way to 0. So when you write out your rate equation, remember that step 1 is the material balance. And now step 2, you have a rate equation. And so what is the rate equation for this one? Well, I guess I already wrote it on the board, right? So that's the consumption rate of A. What is the rate equation for that problem, though?
Same one, except you don't subtract the reverse.
Yeah, I have to take into account that it can react in the reverse direction. So you get now K minus 1 times the concentration, not of A, but of B. A lot of times, though, you're not going to be given the two rate constants. You might be given K1 and the equilibrium constant. So how can I get the reverse rate constant from the forward rate constant and their equilibrium constant? Right? What is the equilibrium constant equal to? Products over reactants. So in this case, concentration of B over the concentration of A. What else is it equal to? Yeah.
Isn't there an assumption that needs to be made to be able to say that?
The only assumption here is that the concentrations I've put inside that equation are at equilibrium.
Okay, so I thought it had to be like a PSSA assumption kind of thing to be able to use that.
No. Now that would be, no.
Because
I know what you're going after,
Because like you
but
said the rate law equal to 0, then you can solve for K1 over K negative 1.
yeah. So if I have a system of two reactions, if I have A goes to B, so we'll do that real quick.